This is conditional probability. So an example question is, in a group of 18 people, 9 have dogs, 11 have cats, and 5 have both dogs and cats. Find the probability the person has a cat given that they have a dog. Now this is pretty much about what given that actually means. So we'll very quickly pop this in a Venn diagram just so we can see these regions. I've got cats and I've got dogs. There's 18 people, 9 have cats. 9 have dogs and 11 have cats because cats are much better. And 5 have both dogs and cats, so it's 4 people with dogs only, 6 people with cats only, and 10, 15, so 3 who don't have a pet. So we've got our little Venn diagram. Find the probability that a person has a cat given that they have a dog. This is basically saying, assuming that your people have a dog, so taking this out of only the dog people. It's a given that they've got a dog. Nobody else counts, not these people, not those people. We're only looking at the dog people, which is 9. What's the probability that those dog people have a cat? And quite obviously this is 5, the people who have a cat and also have a dog, out of the total number of people who have a dog. So our notation is probability of cat given dog. So this pipe bar symbol means given that, so it's C given D. Cats given dogs. And the probability out of the people who have dogs that they also have a cat is 5 over 9. So that's what the given that questions are asking. Now your notation that you need, if we take that back to our old friends A and B, the probability of A given B is going to be the number of elements in the intersection of A and B, that is N, A and B, divided by the number of elements in B. If I was asked for the probability of B given A, then it's still the number in the intersection A and B, but we take it out of the total set in set A. So it's reading out of the items or elements in set A, what's the probability that they're also in B? So the second one is the one that will be our total sample space. We're actually reducing the sample space to the set B or the set A. That given that reduces our sample space. You can also do this with two-way tables. So this is example 9 in your textbook if you want. We've got a group of hockey players at a game, 15 of them. 13 played on the field, 7 sat on the bench, and 5 both played and sat on the bench. So if we choose someone at random, then find the probability, so PR, that a person played on the field, given that they sat on the bench. And we'll also find the probability that a person sat on the bench, given that they played on the field. So, the probability of F given B is going to be the number in the intersection of F and B divided by the number in set B. The probability of B given F is still the intersection, but the sample space is now the set in F. So, have a look at where the regions are. The number in set B is of course just the total of B. So this is out of 7. The number in the intersection is both, 5. The intersection is still 5 for this one, but this is now out of F, which is 13. So it's a reasonably simple concept. You've just got to understand the notation, remember the formula and what matches up with out of A and the sample space of A, and of course learn the language of given that.